Warm greetings, friends and dear students. Now we are going to see about the video lecture on the strain energy due to the shear stress. So when a beam is subjected to the direct shear stress, that is tau, what will be the total strain energy stored? So therefore, the strain energy stored due to the shear stress is equal to capital U is equal to integral of 0 to L tau square into dV divided by 2 into G, capital G, that is the shear modulus of the material of the beam or any structural elements. Or you can put the strain energy is due to shear stress is U is equal to tau square into capital V divided by 2G, where capital G is equal to shear modulus of the material of the beam in terms of Newton per square millimeter, and capital V is equal to volume of the given material of the beam, and tau is the shear stress in terms of Newton per square millimeter. So this is the equation used to find the strain energy stored due to the shear stress. The next we are going to see about the strain energy stored due to the direct shear. The direct shear is denoted by capital F. Therefore, the strain energy stored due to direct shear is capital U suffix D, that is direct shear, is equal to F square into L divided by 2AG, where F is the direct shear and L is the length of the beam or any material of the body, and capital A is the area of the beam cross section, and G is equal to the shear modulus of the beam material. Or you can give strain energy U is equal to integral 0 to L F square into dx divided by 2A into G. So if you are integrating from lower limit, what is 0 span of the beam to the maximum span, for example 3 meter, you can able to find the total strain energy stored due to direct shear. And the next one is, what is the strain energy stored due to torsion? So U suffix T is equal to total strain energy stored, that is equal to T square L divided by 2G into J, where T is the applied torque or the twisting moment, and L is equal to length of the torsion of the shaft, and G is equal to shear modulus in Newton per square millimeter, and J is the polar moment of inertia in meter to the power 4 or millimeter to the power 4. For example, for a circular section of the beam of diameter small d, the polar moment of inertia value capital J is equal to pi d power 4 by 32, where d is the diameter of the solid shaft. Or if it is a hollow shaft, that also can be determined. It is pi by 32 capital D power 4 minus small d power 4, where capital D is the external diameter and small d is the internal diameter of the hollow shaft. Or you can give the strain energy due to the torque or the twisting moment is equal to integral 0 to L capital T square into dx divided by 2Gj, where Gj is the torsional rigidity of the shaft material. And the next one, that is strain energy due to the transverse shear. What is the transverse shear? In the case of beam, we are supported on a simply supported or cantilever, whatever it is, the shear, the vertical shear will be occurred in the case of a beam, right, cross section, that is called as a transverse shear. So the strain energy stored capital U is equal to K into V square L divided by 2G into A, where V is the volume and L is the length of the beam and G is the shear modulus of the beam material and A is the area of the beam. Or you can give 0 to L into K into V square dx divided by 2G into A. So if you are substituting in terms of, right, when the lower limit x is equal to 0 to x is equal to L, that is at the end of the span of the beam. So that way also you can find the strain energy. So in this video we have seen about the strain energy stored due to the shear stress, first one, and the second one is what is the strain energy stored due to direct shear, and third one we have seen about what is the strain energy stored due to the torsion or to the torque, and the last one, that is fourth one, is what is the strain energy stored due to the transverse shears in the case of beam. So these are the equations which are used for finding the strain energy stored due to the different conditions of either direct shear or shear stress or the transverse shear or to the torque. So in the next video we can see about the numerical problem in these four conditions to find the total strain energy stored. Thank you very much for patient listening. God bless. வாழ்க வையகம், வாழ்க வளமுடன்.